Oh, there it is. V-volt overview. Oh, there it is. We got OBC temps, and everything looks like it's communicating.
Nice. So,
All right. Your car is live. Or I should say Tim's car it has a brain.
Exciting.
So it's no longer just Frankenstein sitting there on the bed or the gurney. We actually have full communication with the car right now. As you can see, my laptop's been open here for a while. It's just on the phone with AEM, and they are helping me calibrate some of the new flashes and firmware for this vehicle. It's our own firmware, so we kind of help them design what we want for our particular builds. And that's what we're kind of going through right now, is to make sure that this is updated with the most current software that we use here in-house. Well, so when you plug in the charger, the pumps turn on. If it gets too warm, the fans automatically cycle on and off. So all that is already kind of baked into the cake. So now I'm just connecting to the car. And you guys got a USB port inside there. Look at that. All right, so basically what it's showing me is this is all your CAN network and all the protocols and CAN messages going back and forth on the network right now. That means it's live. You can see it's online, and that's all the data that's being communicated back and forth on the CAN channel. So basically what my computer's doing right now is it's monitoring all the components that we just installed. So we have our battery management systems for the balancing, the BMSs. Those are all here. And then we have our onboard chargers. It shows me the temperature of the DC to DC as well. So what that does is it steps down that large high voltage into 12 volt. Because this car still has a 12 volt system to run the headlights, windshield wipers, radio, and also all the computer systems are based off the 12 volt system as well. Everyone's like, well, why do you have a 12 volt battery in these EVs? Because that runs the brains. The big pack, the high voltage stuff, runs the car. So they're two completely separate systems. But in the middle there is an integration between the high voltage and 12 volt, because we got to keep that 12 volt battery charged. And since this isn't a combustion engine, it no longer has an alternator. So the alternator can't charge the battery. So we have to kind of make up for that. And that's what the DC to DC step down does. It takes a high voltage, drops it down about 13.8 volts, and then that pushes into the 12 volt battery to keep everything happy. So the 12 volt batteries in these cars do nothing more than just turn on the brain. So that's what's going on there. Once we get more into this, we'll have our charge states. We do not have the high voltage pack in here right now, so this is empty. And all of our BMSs are showing zeros because we have not installed the high voltage in this vehicle yet. Right now, we're just basically testing all the CAN channels, making sure all our CAN networks are run correctly. We got 5 networks in this car?
Yeah.
Okay, so that 4 of them are like for the dash, the displays, the keypads, the charger, the vehicle control unit. Those are all on different networks and protocols. And then the BMSs are on an ISO-SPI. Sorry to get geeky on here, but that's basically its own network that talks just with the BMS.
So your plan today is to put in the...
To get all the computers up and happy and communicating with my laptop, which we just finished. So,
how long did that take?
It was kind of a process for the last couple weeks. We were trying to get some different firmware in here, and then we didn't have the whole entire system all put together until today. Okay. Actually, yesterday we wired it all up and got it completely kind of all on the same network. And what we did today is we plugged in my laptop, pushed a new firmware for it, because those VCUs come in pretty much with the base flash on. There's really not much there. So we have to then come in and program all what we want it to do. Blinking lights means something is happening.
I see lights.
Blinky lights are cool. Red lights mean there's a fault because we don't have high voltage connected to the vehicle yet. So that's why we're seeing a red light there. But that means that it is understanding what is going on in the car. It's seeing that there's a problem, and it's already telling us there's an event going on, which is what we wanted to see today when we fired this thing up. So yeah, we're really excited about having this thing together. The wiring is pretty much...
It's getting wrapped up.
Wrapped up, yeah. No pun intended there, right?
The high voltage we're about to start on, but the low voltage pretty well there, yeah. This
is just one set of wires that had to be pulled through the vehicle. Now this is going to the motor, the dash, your selector switch, so you go park neutral drive, your communication lines, 12 volt that's all sitting in these looms. There's one down this side, and there's a bunch more in the back that tie all the BMSs together too.
Yeah.
We just literally added over 300 wires to this car. So that has to be tested pretty thoroughly. What we're going to do is run it through a couple charge cycles, and that's why you want to put miles on the car. You want to bring the batteries up, you want to bring the batteries down a few times to see kind of if it's performing correctly and if all the batteries are balancing correctly. And that's not something that happens overnight. That happens over a course of 4 or 5 charge cycles. This is a car that we can't really drive, so we're going to have to improv, put it on a dyno.
Okay.
So where we are with the car right now is all the main wiring's in.
Okay.
We do have to still install the batteries for the high voltage, and the reason we keep that towards the end is because that's the most volatile part of the car. We don't want to accidentally step on them, we don't want to drop a wrench down inside there. So the further we could get away from the high voltage while we're building these things, for safety reasons, we try to do that. You'll see that our wiring harness is already installed. So all I have to do is literally connect these cables to the motor, and the motor will fire up. Today is get the motor in, connect it all up, get it all ready to be plumbed for cooling. Also, what we need to do is make sure that the computer is responding with this particular wiring harness, because the wiring harness we used to program the motor yesterday is sitting on that bench. That's a different wiring harness. Everything we do here at Revolt, we test with the products that are going to go with that motor. So this particular wiring harness was tested on a previous motor. We decided not to use that motor because we painted this one. And now all the componentry has changed. So we're going to put it in here, make sure everything's good, run some diagnostics on it, make sure all the cans are communicating properly on the motor side. We get throttle input. Throttle is already in the car. Once that's all set, then we could concentrate on the high voltage side. And high voltage is basically, it means getting power to that big motor that's going to be sitting in front here to move the wheels. So a lot of fun stuff. We did the electronics, booted everything up today to make sure everything works. And this work of art is ready to go in the car. Almost. You guys ready to do this?
What you're doing? Let's do it.
Well, yeah. I mean, we got a bunch of monkeys standing around. Let's put them to good use. I could go real slow, make it all like super dramatic. Dun, dun, dun.